Hey everybody, it's Miss Bryant, and I am here to walk you through some problems with perimeter and area of composite figures. So here's my suggestion for what you do. I think you should have some paper with you. You should have your Math 8 pre-algebra formula sheet handy dandy. That can be pulled up on my website if you don't have it with you. Look in the unit resources under Unit 5, and you will find the link for the formula sheet. And a calculator. You can, if you have Desmos, on your phone, that's great. If not, there's also a link for Desmos on my webpage underneath where it says YouTube and other links. So you'll need Desmos, something to write with, something to write on, and your formula sheet. And so what I suggest you do is that as we go to each problem, I'm going to talk about what the problem wants and then tell you to pause. You should hit pause on the video, and then you should work out the problem, and then hit play and watch me work out the problem and see if you get the same thing that I got. I think that would be the best way to go through. If you didn't get the same thing I got, you could back up and watch it again. And if you do that and you still can't figure out your error, send me an email or comment on the video. Make sure you use your name so I know who you are, and I can help you figure out where you went wrong, okay? So we're going to start first with 4 problems finding the perimeter of composite figures. And remember that perimeter means the distance around the outside, okay? A lot of kids just say, oh, perimeter is the outside, but they don't really know what it is about the outside. It is the distance around the outside, how far you would have to go if you walked around the outside of the figure, okay? So we're going to start with this house-looking figure right here, and this is a really easy one. You may remember that when you see these marks tell you that the segments are the same length. So since both of these segments have the double mark and one of them is 4 centimeters, that means the other one is also 4 centimeters. For this mark, these would both be 6 centimeters. And for the bottom, we already know that it's 5. So basically all we need to do is add up all the sides. Now, in order to make sure that you don't miss one, I always like to write the number down and then sort of squiggle out the side. So there's the 4 plus this 6 plus this 5 plus this 6 plus this 4. And I can see that I have all of the sides done. I'm not missing any, so I know if I add this up, this is going to be right. Excuse me, I'm sorry. 4 plus 6 is 10. 6 plus 4 is another 10. 10 and 10 makes 20. Plus this 5 right here makes 25. So the answer to this problem is 25 centimeters. All right, here's the next problem. Go ahead and pause the video and try it on your own. All right, so now for this problem, there's going to be a side that we don't know. Since I know that this bottom part is 6 centimeters, and since this is a rectangle, we know that rectangles have the same side lengths. So I know that the top part is also 6 centimeters. So that gives me 6 plus 4 plus 6. But here we go. I don't know how long this is. So I am going to have plus something. Excuse me, 1 second. So in order to find out this whole perimeter, I'm going to need to know the distance around that semicircle. So first thing I need to know is how to find the distance around a circle. The perimeter of a circle is called circumference. And if you look on your formula sheet, there are 2 formulas for circumference. Pi d, and you know d is diameter, or 2 pi r, and r is radius. So what I always do is look at the picture and see what they give me. I know that this distance is 4. I also know that if I drew the rest of the circle in, if I could see the whole circle, this would be the distance all the way across the circle. That is the diameter. So I should use this formula right here. And I should use pi. We always use 3.14 for pi. And then 4 is the diameter. Now, when I multiply 3.14 times 4, and I need to turn my calculator on, we get 12.56. But we have to stop for a second and think. That would be the distance all the way around the circle. But I don't want to go all the way around the circle. I only want half of the circle. So I need to take this number and divide it by 2. This is where most students make their errors. So 12.56 divided by 2 gives me 6.28. That is this, and that's the number that's going to go here. So now I have 6 plus 4 is 10. 6 plus 6.28 is 12.28. 10 and 12 is 22. So 22.28 centimeters would be the final answer. Moving on to the third one, go ahead and pause the video and take a stab at this one yourself. All right, so let's look at what we have. I see this mark here that says 5, and I see lots of other marks like that. So I know that these 3 sides are 5 meters. So what I know right now is 5 plus 5 plus, I'm going to say 10, because that's both of these. So what I'm missing is this part right here. Now, if I thought about a whole circle, in order to get this length, I would actually have to cut this circle into quarters. This is 1/4 of a circle. So I still need my circumference formulas, and I could use, again, either one. But I have to think about what I know about this circle. I know that this distance right here is 5. On my picture of the whole circle, that translates to this. Well, that means that this point right here is the center of the circle, okay? If I were to draw the whole circle all the way around, this 5 right here would end at the center, which means 5 is actually the radius. So I'm going to use the 2 pi r formula. 2 pi radius of 5. That gives me 31.4. But that would be, again, the distance all the way around. I don't want to go all the way around. I only want to go 1/4 of the way around. So I'm going to divide that by 4. And I get 7.85. That goes right here. Now I can add these up and see what I got. 5 plus 5 is 10. 10 and 10 makes 20. 20 and 7 is 27, so 27.85 meters is the perimeter of this figure. And here's our last perimeter problem. Go ahead, pause the video, and take a minute and see if you can figure it out yourself. All right, so we're back, and I know that this little mark means 12. So this is 12, the dotted line, but also this part of the triangle is 12. This part is 32 because I have a rectangle here, and the top is 32, which means the bottom is also 32. So this whole side is 12 plus 12 plus 32, which is, let's see, 32 plus 24 is 56, I think. Okay, 56. So if I'm adding up the things that I know the top is 32, and I know the whole bottom is 56. You could write those separately if you wanted to. What I don't know are these angled sides. And hopefully you remember that when I told you on these kind of problems you ever had to find an angle side, you would probably be using the Pythagorean theorem. Let's take a look at this section of the picture right here. we have ourselves a right triangle. The bottom is 12. This side is also 12 right here. And I'm looking for the hypotenuse. I'm going to erase this for a second just to give me some space. So I need to use the Pythagorean theorem. A squared plus b squared equals c squared. The hypotenuse is c, so 12 and 12 are my a and b. That's 144 plus 144. That's 288. Now, remember at the end of the problem, that's not all, because 288 would be way too long for this. Remember, the hypotenuse is the longest side, but it's not long by too much. It's only long by a little bit. 288 is way longer than 12. So remember, at the end of the problem, you must square root both sides. And the square root of 288, let me get my calculator, is 16.97 and a whole bunch of other stuff. So if it's 16.97, let's go ahead and round it to the nearest whole number. I'm going to say it's 17. So that means this side is 17, and so is this one. Don't forget we had two of those. I know that this triangle here is the same as the other one because of the 12 and 12, 12 and 12. So I don't have to do that math twice. So I'm going to add these up now. And let's see if I can do this by mental math. 17 and 17 I know is 34. 32 and 34 is 66. 60 and 50 is 110. 6 and 6 is 12. That gives me 122 centimeters for the perimeter of this figure. All right, so how'd you do on those? Leave me a comment down below with your actual name and let me know how you did on those. And let's go to area. So remembering area, a lot of students say, oh, area is the outside. But the question is or the inside rather, what about the inside? It is the amounts of space covering the inside of the figure, or the space that it takes up, all right? So for example, if we're looking at a square, perimeter would be how far you had to walk around the outside. Area would be the amount of space that the whole inside takes up. And remember that for area, we measure it in square units, because what we're really doing is counting how many little squares could fit inside this figure. So for this square I just drew, it's 16 square units, okay? So let's go ahead and take a look at our first one. So we have a few problems here that are shaded figures. And remember that for the shaded, when they ask you to find the shaded area, you are basically doing the outside area minus the inside area. All right. In order for me to find out this right here, if I want just that part, what I'm going to have to do is find the area of the whole thing and then subtract the inside part. All right. And that gives me that shaded area. So we have two circles. All right, I have this big circle, that's the outside one, and I have the little circle, that's the inside one. So let's do the area of the outside. I'm going to say AO. And on your formula sheet, you see that the area of a circle is pi r squared. So pi is 3.14. The question is, what is the radius of the outside? It is not 3. 3 only goes from here to here. We need to go from the center of the circle to the edge. The outside radius is actually 8, okay? 5 plus 3 more. So this is going to be 8. That's 3.14 times 64. And if I do that on my calculator, I get 200.96. I'm just going to call that 201. If you didn't round it, that's okay. As long as all your math is the same as mine, it's okay if your final answer is rounded differently, okay? So boy, I shouldn't have done that so big. So my outside area is 201. I'm going to write it there, and then I'm going to erase all this so I have room. I should have done it smaller, sorry. Okay. Now my inside area, AI, is also pi r squared, 3.14, and this time the radius is indeed 5. From the center to the edge of that little circle is 5. So 3.14 times 25. Don't forget, we have to do order of operations, so we have to do our squaring first. That gives us 78.5. Whoops, I just dropped my pencil. 78.5. So, in order to find the area of just the shaded part, we're going to subtract. 201 minus 78.5. If you rounded that to 79, that's okay. We get 122.5. This would be inches squared, okay? If you made it 79, then you got 122 even. As long as you did all the other math just like I did, your answer is fine. Okay? We have another shaded area problem. Go ahead and take a minute and try this one. Pause the video. All right, let's talk about this guy. So it's going to be, remember, outside minus inside. Our outside shape is a triangle. Our inside shape is a rectangle. So we're going to do triangle minus rectangle. The area of a triangle, if you look on your formula sheet, is 1/2 base times height. The area of a rectangle is length times width. So let's talk about our triangle first. You may remember, hopefully, that I told you guys that the base and the height would always make a right angle. Well, if we look at this triangle, it doesn't have a right angle. So you know what we have to do? We have to draw a line down the middle and create one, okay? If we dropped a straight line from the top of the triangle down, this would be a right angle. So our base is going to be across the bottom, and our height is actually right here, which we are finding out is 20 meters. The base, we have 2, 2, and see right here, 15. So our base is 19, all right? So we're going to have 1/2, base of 19, height of 20. I'm going to do it this way. Half of 20 is 10. And that gives us 190. You could multiply both and then do times 1/2. You're still going to get 190. So there's our triangle. Minus our rectangle, length and width. Let me erase all this stuff out of the middle so I can see what I'm looking at. The length and width of my rectangle are here and here, which is 15 and 4. So 15 times 4, and that is 60. 190 minus 60 is 130 meters squared. There is the area of our shaded part. All right, let's roll to the next one. We have another shaded figure. Go ahead and pause the video and take a shot at this one, and then play it again when you're ready. All right, so outside minus inside. Our outside shape is a circle. Our inside shape is a square. And I know it's a square because I can see that this is 10 and this is 10. So squares have the same side length on all sides. So circle, pi r squared is the area of a circle. Square, length times width, same thing as a rectangle. All right. So for the circle, I know what pi is, but I need the radius. Here's the center of the circle. Some students would say that it's 5 because they're looking at this and they're thinking it must be half of 10. But take a look. This does not go to the edge of the circle. I need to go all the way to here. And I don't have any idea what that distance is. So 5 is not going to cut it. However, if I think of my radius, if I take my radius and put it at an angle to the corner of the square, that hits the edge of the circle. So this is my radius. Here's what I'm going to do. I'm going to draw it all the way across and make a right triangle. Look at that. This is 10, and we'll be finding the what? Hypotenuse. So I'm going to use the Pythagorean theorem. 10 squared plus 10 squared equals c squared. 100 plus 100, 200, square root it. Let's see what the square root of 200 is. Whoops. I accidentally squared it. There we go, hit the rock. Okay, it's 14.14. You know what? I'm just going to call it 14. If you kept it at 14.1, that's perfectly fine. Now, that's the distance all the way across, but the radius is only halfway across. So my real radius would be 7. Okay? So if I come back over here to my circle formula, that's what I'm going to put in there. 7 squared is 49. 3.14 times 49, 153.86. Let's call that 153.9. It's close enough. Actually, let's call it 154. Why not? And our length and width of our square is 10 and 10, which is 100, which gives me, whoops, I almost said 144. That gives me 54 centimeters squared. All right, like I said, if you didn't round, that's okay. Whatever number you used, you're going to be taking away 100, and if you got the right answer, then you're good. This was a complicated problem because on the last one, we could see very clearly, or this one rather, no, where is it? When we had to this one, we could see in the picture the diagonal was already drawn for us, and it's pretty easy to see the triangle because it was already there with the little right angle in the corner and everything. On this problem, we had to create the triangle ourselves where there wasn't one there to begin with. If I erase all this stuff off, you don't see a triangle in this picture. So you had to imagine, what if I drew this? What if I drew that? I could make a right triangle, and then I could use this, formula. So you have to be willing to kind of be flexible in your thinking on that. Let's go to the next one. We have another shaded area. I think this might be the last shaded area problem. So go ahead and pause the video and take a stab at this one. All right, we are going to do, again, outside minus inside. So our outside shape is a rectangle. Our inside shape is a circle. So rectangle, length times width, circle, pi r squared. The length and width of the rectangle we can see very easily are 10 and 6, and that makes 60. I know that pi is 3.14, and here we go with the radius again. Now, a lot of students are used to drawing their radius horizontally like this, but this doesn't help us because I don't have any idea how far this is, so I can't figure out the radius that way. You have to be flexible and think about, well, what if I drew my radius going like this? Well, that would be half of this total distance, right? Because this is the diameter up and down. That's 6, which means the radius is 3. 3.14 times 9. Let's see what that is. 3.14 times 9 is 28.26. I'll just leave it like that. And we'll do 60 minus that, and we get 31.74 centimeters squared. If you rounded this part and got something else, that's okay, as long as you did all the other math correctly. All right, let's roll on to the next one. Now, we're not doing shaded area this time. We're just doing regular area. So when we have regular area without having to subtract, we are adding the areas of the different shapes that we see. However, here's what I notice about this shape. It is really a trapezoid. No matter how I turn it, actually this was the original way, and sure enough, it looks like a trapezoid right out how it is. So the area of a trapezoid, if you look on your formula sheet, is 1/2 h times b1 plus b2, okay? 1/2 the height times b1 plus b2. So let's see if we can substitute numbers. 1/2, the height of the trapezoid is right here, which is 12. And then we have b1, which is right here. b1 is also 12 because see the little mark? That's helpful. And b2 is right here, which is 17. So 1/2 times 12 times, let's see, that's 29. Half of 12 is 6. And 6 times 29, let's see, is 174 centimeters squared. So a lot of times students make this problem harder than it needs to be. Let me erase this stuff so you can see. They think to themselves immediately, okay, I have to cut this shape. So let me draw a triangle right here, and I'll do the area of this triangle, and then I'll do the area of this square. And of course, the area of the triangle is a big giant pain in the butt because you need to know what this length is, and so you have to figure it out. And it's like, why you don't have to do any of that work if you look at the picture and realize that what you have is a trapezoid, and the trapezoid's already on your formula sheet. So be careful about these problems that you don't make more work for yourself. Let's go to the next one. Now for this one, we are going to have to split it up, but there are several different ways to do it. I'll show you 2 ways. Go ahead and try this problem. Hit pause. All right, so there's 2 ways we can do this. We can add 3 different shapes. I can draw a line here and draw a line here and have 1, 2, 3. That's one way. I can draw a line here, whoops, and here, 1, 2, 3. Or I can draw a line here, make a whole rectangle, and then find this rectangle and subtract it out. Kind of do like one of those shaded area problems, all right? I'll show you all 3 ways because I don't know which way you did it. So I'll draw the vertical lines right here. This will be 1, 2, 3. If you notice that shape 1 and shape 2 are the same shape, that makes life a little bit easier. So I have 3 rectangles. I have rectangle 1 plus rectangle 2 plus rectangle 3. Length times width, length times width, length times width. So rectangle 1 is the length is 15 and the width is 11. So 15 times 11, that's also the dimensions for rectangle 3, 15 and 11. So that takes care of these 2. Rectangle 2, I know that this right here is 11, but I don't know what this is. However, I can find it out. I know that the full distance top to bottom is 15. I know that this distance right here is 9. So what would I have to add right here to 9 in order to make 15? It would have to be 6. So 11 and 6 are the dimensions of that rectangle. Now it's just a matter of multiplying and adding. 15 times 11 is 165. Add all 3. And I get 396 millimeters squared. Okay, I'm going to put that up in the corner here because when we do this problem 2 other ways, we should get the same answer. If we don't get the same answer, something is wrong. So I'm keeping my fingers crossed because I'm about to do this live on this video, and it would be terrible if I made a mistake. Well, it wouldn't be terrible, but you know. All right, let's do it the second way, which was drawing a line across like this. Rectangle 1, rectangle 2, rectangle 3. Again, we're going to be adding these 3. Now, 1 and 2 are the same size, so that helps a lot. The length and width of this rectangle, the length is 11. Be very careful that you don't say 15 for the width, because 15 goes all the way down. We need this little piece, which happens to be 9. So 11 times 9 plus another 11 times another 9. That's for this one. And then we need to look at the rectangle at the bottom. I need this distance all the way across. Well, if I take 11 plus another 11 plus another 11, that makes 33. And then I need to know this distance. Again, it's not 15 because 15 goes all the way. I do know if this is 9, that this part right here is 9. So remember, we just said that that had to be 6, right? So 6 and 33 would be the dimensions there. So 99 plus 99 plus, I don't know what 33 times 6 is. Let's find out. 198. Cross your fingers. I'm about to add these numbers, and yeehaw, 396. All right, so that's your second option for doing it. Option 3 is to do a subtraction. Let me put that back up there. So I'm going to do like, if there was a line here and this was like the shaded, find the shaded area. All right. So it would be outside minus inside. The outside shape is the big rectangle. The inside shape is the little rectangle. So we have rectangle big minus rectangle little. So length times width minus length times width. If I'm looking at the big rectangle, 15 is the width. And remember, we just said this distance all the way across was 33. So 15 times 33. For the small rectangle, it's 9 by 11. So 15 times 33 is 495. 9 times 11 is 99. And 396 is your answer. All right, so there you go. Whew, that was a long problem because we did it 3 ways, but we got the same answer every time, which, phew, thank goodness. Let's move on to the next one. My iPad is flashing low battery at me. Let's see, I'm going to plug in my phone charger. Hopefully that is going to work. We'll see if it does. Okay, so this one we definitely have 2 shapes. Shape 1, I have a square, and shape 2, I have a quarter circle. Remember, if this circle was drawn all the way, it would look like this, and this is a quarter of it, okay? So we're gonna make sure, let me take that out, that we have a quarter circle. And we're going to add these 2 together. So it's gonna be square plus quarter circle. All right, the area of a square, length times width, quarter of a circle, pi r squared. And if you want to go ahead and write divided by 4 so you don't forget, that probably would be good. The length and the width of the square are 5. 5 times 5, because see the little marks? So these are all 5. 5 times 5, pi radius. So remember, I'm going to come down here. If I have a whole circle, and this is the piece, the radius goes from the center to the edge. So looking at my picture, it is this side right here. Let me draw it in red, right here. So this really is the radius, which is 5. 5 times 5 is 25. I don't know why I put the parentheses there. Why not? 3.14 times 25. All divided by 4. So I need to figure out what this is. So I'm going to do 3.14 times 25 equals divided by 4. And I get 19.625. Let's round it to 19.6 plus 25 gives us 44.6. And this would be meters squared. Okay, that's our area for that one. Moving on, we have this sort of bullet-shaped object. Again, we're going to be adding to find the total area. We have shape 1 and shape 2. Shape 1 is a rectangle, and shape 2 is a half circle. Rectangle is length times width. Circle is pi r squared, but we're going to have to divide it by 2 because it's a half circle. The length and width of the rectangle are 4 and 6. That's pretty easy to see. Pi is always 3.14. Now the radius, if we drew the rest of this circle, the radius would go from here, center to the edge. So I need basically half of this distance. I know the whole thing is 4, so half of it would be 2. So our radius is going to be 2. So 4 times 6 is 24. This is 3.14 times 4 divided by 2. 4 divided by 2 is 2. 3.14 times 2 is 6.28. So this gives us 30.28 centimeters squared. If you rounded it, that's okay. And that's the end. All right, I'd be interested to know if you want to leave me a comment below. If you went through all the problems with me, how did you do? Leave me a comment. Please write your actual name. Guys, I don't know your YouTube names, so if you leave me a comment with some crazy YouTube name, I don't know who you are. Please leave me your actual name and let me know how many you got right. I'd be curious to know. And I will see you for the next time. Bye.